Hello, Glendale Community College students. We are here with our Chem 130 Chapter 12. We are going to be talking about liquids and solutions in this chapter. Now, this chapter is pretty long and will most likely last a couple of weeks during the regular semester. So let's get started. We're going to review chemical bonds first of all. Now, chemical bonds hold atoms together in a compound. They are the connections between the atoms in a molecule or a compound. We have ionic bonds, which typically form between a metal and a nonmetal. So remember, metals are on the left side of your periodic table, and there's mostly metals in the table. Nonmetals are the elements on the right side of the stair-steppy line in your periodic table. There's far fewer nonmetals than metals. An ionic bond has electrons transferring from the metal to the nonmetal. So this means the metal loses a negative electron, which makes it more positively charged, and we call it a cation. Cations are positively charged. The word cat is in there, right? For cation, and cats are positively charged. They have positively charged. The nonmetal gains the negative electron, so it becomes more negative. So it becomes negatively charged, which we call an anion. Now, these oppositely charged ions are attracted to each other just because opposites attract. Pluses and negatives attract each other. And that's the basis for an ionic bond, right? Great. Now we have covalent bonds as well. These form between the nonmetals with other nonmetals. The bonding electrons can be shared between these nonmetal atoms, and they can be shared equally or unequally. So that brings us to reviewing polar and nonpolar, which is very important in this chapter. Now remember, only covalent bonds are polar and nonpolar. Okay, so we're talking about nonmetal bonds. So bonds with C, N, O, F, P, S, Cl, Br, and I. Non-metal bonds. Okay, let's start with polar. A covalent bond is polar when the electrons are shared unequally. This means one atom has the electron shifted over towards it more than the other atom. So this is due to electronegativity differences. So the atom that's closer to fluorine is more electronegative, and it will pull those electrons closer to it. So the more electronegative atom, the one closer to fluorine, pulls electrons close, so it's a little bit negative because electrons are negative. The other atom by default is a little bit positive. And remember, we use those delta symbols to indicate a little bit positive and negative. So because one atom's a little positive and one atom's a little negative, we have two poles. We have a plus and a minus, two poles, so polar. Polar means we have poles. Okay, the bond is polar. We have two different atoms, right? They have to be different from each other in order to be polar because they have to be different in electronegativity. So two different nonmetal atoms. All right, now let's go to nonpolar. This is when the electrons are pretty much shared equally right in the middle. So there's no or only a small electronegativity difference. So this means the electrons are shared between two atoms that are the same. O to O, C to C, H to H, Br to Br. The atoms are the same. Or our exception is a CH bond. Carbon and hydrogen have a very small electronegativity difference. They pull the electrons about the same. So again, the electrons are in the middle. Because an atom is not pulling the electrons to one side, the electrons are shared equally. So there's no poles. The electrons are in the middle. So neither atom is a little bit plus or a little bit minus. There's no poles, so it's nonpolar. Again, atoms that are the same or CH are nonpolar. Okay, so review this. Rewind and watch this again if you need to. This is very important for this chapter. All right, intermolecular forces are going to be abbreviated IMF in this chapter. IMF, intermolecular forces. These are attractions that hold molecules together in a liquid or a solid. So why doesn't the ocean fly up and evaporate away? What keeps the ocean liquid? Okay, it's not gravity. Gravity's not holding all the little water molecules down. If gravity did that, everything would be smushed together. So that's not it. So there's something else going on. What keeps the ocean liquid? Well, it's the attractions between H2O molecules and other H2O molecules that keep it liquid. Same thing in certain solids. So here's a picture of water. We have an H2O in white and a second H2O in white. Bonds are between the atoms within the molecule. So the HOH in white, those white sticks are bonds. They are covalent bonds. The dotted yellow line between the two molecules is the force, the intermolecular force. Now, intermolecular forces are weaker than bonds. Okay, bonds are stronger than intermolecular forces, IMF. Okay, so this picture is really good. The white lines are bonds. The yellow dotted line is a force, an intermolecular force. Forces are between molecules. Bonds are between atoms. Okay, so again, if I just have one HCl molecule, what holds the H to the Cl is a bond, a covalent bond, and it's the red dash in that picture. Okay, that's just one molecule. The H is held together with the Cl by a bond. Now, when I have a bunch of HCl molecules, one HCl molecule is held with another HCl molecules by the force. So in this second drawing, the dashed red line is the force. It's between the HCl molecules. The black line is the bond. So we have an H bonded to a Cl with a black line. That's one molecule. That is a bond. Then we have the red dash line. That's the force, the intermolecular force between the other HCl molecule that has a little black line, which is the bond. So again, bonds hold atoms together within a single molecule. Forces hold molecules, plural, together. So intermolecular forces are attractions between molecules, and often in a liquid, but it's also gas or solid. They are electrical in nature. That means we have charges. So it's between a partially positive charge, delta plus, and a partially negative charge, delta minus. So intermolecular forces are just attractions, opposites attracting. You're going to see that in all our examples. Intermolecular forces are attractions between a little bit positive part and a little bit negative part of two different molecules, and so the molecules are attracted together. Okay, remember, you've got to know your polar versus your nonpolar for this chapter, so review that again if you need to. Okay, that was back in the chapter with Lewis dot structures. So there are four types of intermolecular forces we're going to talk about. There's London dispersion forces, dipole-dipole forces, hydrogen bonding forces, and ion dipole forces. And we're going to talk about those in the next video. All right, that was your introduction to chapter 12. See you later.